Hello students, good morning. I hope you all are safe and healthy at your home. Welcome in lecture number. In last lectures, we complete the thermal application of solar energy in field of water heating and space heating and power generation. Now, in this lecture, we studying about space cooling and refrigeration and one more thermal application, distillation. So, we start with space cooling and refrigeration system. See the figure. This figure shows the schematic diagram of space cooling and refrigeration system. Basic information of this application is here is one cycle for solar radiation absorption. Second cycle is for heat transfer and third cycle is for space cooling. So, this is the system for space cooling and refrigeration system. We discuss about detail of this system. One of the best interesting thermal application of solar energy is for the purpose of cooling, space cooling and refrigeration. Space cooling may be done with the objective of providing comfortable living conditions or of keeping a food product cold. Here see the diagram. A diagram is a simple solar operated absorption refrigeration system is shown in the figure. Water heated in a flat plate collector. We discuss it about in flat plate collector. Flat plate collector is for heating of water. So, water heated in a flat plate collector. Sometimes more than one flat plate collector is arranged, so we call it as array. Water heated in a flat plate collector or array is passed through a heat exchanger, coal generator. So, coal generator, where it transfer heat to a solution mixture of absorbent and refrigerant, which is rich in refrigerant. Refrigerant vapor is boiled off at a high pressure and goes to the condenser, where it is condensed into a high pressure liquid. The high pressure liquid is throttled to a low pressure with the help of expansion valve. Please see the expansion valve in diagram. So, high pressure liquid is throttled to a low pressure with the help of expansion valve, and temperature in an expansion valve and passes through the evaporator coil. Then after it passes through the evaporator coil. Here that means evaporator. The evaporator, the refrigerant vapor absorb heat and cooling is therefore obtained in the space surrounding this coil. The refrigerant vapor is now absorb into a solution mixture with drain from the generator, which is work in refrigerant concentration. This yield rich solution which is pumped back to the generator, thereby completing the cycle. So here complete the cycle by this generator and refrigerant. This yield a rich solution which is pumped back to generator, thereby completing the cycle. The rich solution flowing from the absorber to the generator is usually heated in a heat exchanger by the weak solution which drain from the generator, which helps to improve the performance of the cycle. The efficiency at the last, the efficiency of such system is about 50%. This is the schematic diagram, and this is complete process for space cooling and refrigeration system. With the help of solar energy at our target point or our place is cool or cooling by some refrigerants. We see some other arrangement for space cooling and refrigerant. This is also a space cooling and refrigerant systems. Sometimes this type of arrangement is also provided for space cooling and refrigerant system. Here complete the solar thermal application for space cooling and refrigeration system. I have some videos for this type of application, so it is attached with here. Please see the videos. Now next application or last application for this lecture is distillation. Thermal application of solar energy for distillation. We well known about distillation. So with the help of solar energy, water is boiled and we get distilled water at our required place. So this is very important thermal application of solar energy. Please see the diagram for water distillation. The principle of solar distillation is simple and can be explained with reference to figure in which a conventional basin type solar steel is shown. Please see the figure. The steel consists of a shallow airtight basin lined with a black imper material which contains the saline water. We show also saline water in figure, and please note that it is very important that basin lined with black imper materials, and also it is airtight, so yield of distillation is increased. A sloping transparent cover, we describe it in figure. A sloping transparent cover is provided at the top. Solar radiation is transmitted through cover and is absorbed in the black lining. When solar radiation is Starting the heating, it has heat up the water by about 10 to 20 degrees Celsius. Please note that temperature. Solar radiation heat up water to about 10 to 20 degrees Celsius and cause it to evaporate. So evaporation will be started to gain by this 10 to 20 degrees Celsius. The vapor rise, condense as pure water on the underside of the cover and flows into condensate collection chamber on the side. We also describe the water collection thought, where distillate or a distilled water is collected. An output of about 3 liters per meter square. That means if our instrument is 1 by 1 meter, then output is 3 liter with an associated efficiency of 30 to 35% can be obtained in well-designed steel on a good sunny days. So this is the very important application for water distillation. I have some videos for this type of distillation which is attached here. Please enjoy the video. Some of also arrangement for this type of distillation we also see. See the next figure. Their type of distillation process is also used for the continuous process. In this type of distillation process, sea water or a salty water is input and fresh water we get at a normal rate. This is also a one type of distillation still which is also give the very good efficiency with 25% of the distillation. This is also a one type of thermal application by water distillation. Solar air conditioning system. This is flat plate collector where water is heated and it is stored in hot water storage tank. And this hot water is used in heat exchanger where refrigerant or coolant type materials are heated. This is heat exchanger. And this is desiccant wheel where heat exchange by water to refrigerant. And this cold dry air is supplied to our required place. Solar cooling system. This is flat plate collector heat exchanger, there is one cycle where heated water is passed into heat exchanger where it is exchange heat, and then arrangement of turbine, compressor, condenser, pump, expansion valve, evaporators, and our space where cooling is required. When solar radiation takes place or flat plate collector absorbs the radiation, then it heats the water. This heated water is passed through heat exchanger. This is one cycle. Now second cycle, freon vapors, that is refrigerants, which are heated in heat exchanger and then it passes through turbine, condenser, and that is the refrigerant cycle. Therefore, turbine is converted in mechanical energy. Solar distillation. Feed water in a rectangular type basin. All a day when sun passes, it heats the water. Water evaporated and distillate at inside the top. This is also a solar distillation process. This process is known as passive method. Water is heated in flat plate collector all a day, and this heated water is passed into basin where it heat up and boils the water. So evaporation takes place and water vapor is condensed. Today we will discuss about thermal application in drying and last in cooking. So in this lecture we complete the renewable source solar energy. Thermal application of solar energy in drying. One of the traditional uses of solar energy has been for drying of agricultural product. The drying process removes moisture and help in the preservation of the product. Traditionally, drying is done on open ground. A cabinet type solar dryer suitable for small scale use is shown in the figure. This figure is cabinet type solar dryer. One of also this type of dryer, it is also known as cabinet dryer. This is also a cabinet dryer. First of all, we discuss about this type of cabinet dryer. The dryer consists of an enclosure with a transparent cover. The material to be dried is placed on perforated trays. Here trays are perforated, so circulation of air is very easily. The material to be dyed is placed on perforated trays. Solar radiation entering the enclosure is absorbed in the product itself and surrounding internal surface of the enclosure. As a result, moisture is removed from the product and air inside is heated. Suitable opening at the bottom and top ensure a natural circulation. This type of shows in this type of figures. Suitable opening at the bottom and top ensure a natural circulation. Temperature ranges from 50 to 80 degrees Celsius are usually attained. Please note that very important point. The temperature ranges in cabinet type dryer is 50 to 80 degrees Celsius and the drying time ranges from 2 to 4 days. Typical product which can be dried in such devices are dates, apricots, chilies, grapes, etc. This is cabinet type dryer. Now we see the force circulating dryer, direct gain and indirect gain. This is force circulation dryer. For the large scale drying, the passive device of cabinet dryer relying on natural circulation is replaced by an active device with force circulation as shown in the figure. This type of systems are used for drying timbers. Please note that force circulation type dryer is used in the drying of timber. An indirect type of active device is used when the solar radiation falling. When the solar radiation falling directly on the product is not adequate or the temperature of product needs to be controlled. One such type of system is shown in figure, and also this type of compartment type dryer is used for the large scale. Air is heated separately in and ducted to chamber in which the product to be dry is stored. Such dryers are suitable food grains and product like tea, tobacco, etc. System utilizing solar radiation both directly and indirectly are also used for drying. So this is for circulation type dryer, direct gain and indirect gain. This is also a one type of drying system where directly air is heated in flat plate collector, air circulating flat plate collector, and this heated air is passed at our required place where it is heat transfer and remove moisture from our product, and moist air is exist by blower or any other force circulating equipments. So these are the all types of equipment which is used in the drying process. This is the solar application in drying. Now last application is cooking, and we all are well known about solar cooker. Our last application is solar cooking or solar cooker. Now we see the detailed account of solar cooker. We have different types of figure for solar cooker. Please show these different types of solar cooker. We discuss the solar cooker in detail. Solar energy is converted into heat energy in a solar cooker. Please note that is the principle of solar cooker. Solar energy is converted into heat energy in a solar cooker. Construction of solar cooker is simple as shown in figure. Solar cooker is essentially an airtight aluminum box. Note that it is airtight aluminum box with insulating material between its walls. Solar cooker's box and walls are insulated so heat is not released. The inside surface is color black. We also known about black surface is absorb solar radiation very good. So in solar cooker inside surface is color black to absorb sunlight. Food to be cooked is kept in aluminum containers with blackened lids. These containers also are blackened in outsides. Inside the box, the containers are inside a box. A reflecting mirror. This mirror is also described in figure. A reflecting mirror as shown in figure is also used to collect more of the sunlight. Temperature up to 100 degrees can be obtained in solar cooker. It is very important point, 100 degrees Celsius temperature. So we use this 100 degrees Celsius temperature in cooking of our food. Therefore, temperature up to 100 degrees Celsius can be obtained in a solar cooker. It can be used to roast, to bake, to dry and to cook foods. And very important point is flavor and nutrition are maintained in food cooked in a solar cooker. It is very important point for us today that flavor and nutrition are maintained. Please note that flavor and nutrition are maintained in food cooked in a solar cooker. So This is the solar cooker and last application, thermal solar application in cooking system. Here we complete our one portion, renewable source solar energy. In next lecture we start with biomass, renewable source biomass. I have some videos for solar cooker. It is attached here. Please see the videos. Construction of solar cooker. Parts of solar cooker: wooden box, glass plate, aluminium sheet, mirror, reflecting mirror, slides for moving of lid, plaque containers, food box. These all are different types of now construction of solar cooker. In wooden box, aluminium box is fitted. Blackened line food box is put in this, and with the help of slides arrange reflecting mirror. In food box we put in proper and then it is airtight with help of glass plate. And in a day where solar radiation takes place, reflected mirror reflect the radiation and it is on food box where our food is for cooking. Inside the box and container are in black color, so solar radiation absorb in high rate. Solar cooker, construction of solar cooker, wooden box, aluminium box which is inside blackened, the food is kept in solar cooker and glass cover is closed airtight. When solar radiation takes place, reflected mirror reflect radiation and it absorb in food and time to time it heat ups. There is also provision for open cooking system. Here concentrated paraboloid or parabolic collectors are used, which heat up the pan, and in open we cooking the food. So in these days this type of system is also developed. Today solar cooker is not only a closed system, but it is open also. With the help of solar collecting system, we get 400 degrees Celsius and more than temperature we get by this type of system. For circulating solar type drying system. Extra mechanical force is applied by fan or blower. Air is heated in solar air heaters or flat plate collectors, and this heated air is passed into our crop, which is for drying, is take in this type of system. Hot or dry air is passed on our wet product, and exhaust fan remove moist air, so our product is dried in short time. This is forced circulation type solar dryer. Cabinet type solar dryer. Our food compounds are dried in this type of dryer. When solar radiation takes place, it heats up the material. Material are fed up in perforated trays. Radiation takes place and absorb and eat up the inner area in cabinet. This heated air, this cool air is heated and pass into our product, wet product, where moisture is removed from top of the outside. In a rainy day or in cooler place where extra heating is required, then we put up Bunsen burner. We also use Bunsen burner. solar radiation takes place, cold air is transferred into hot air and is passed into our wet product, which is dried during the day. This type of product is dried in this type of cabinet. Thank you.